This is our circuit. We have J10 inductance, negative J5 capacitance, and a source of 120 volts, phase angle 0, 60 hertz. We calculate the Thevenin impedance very similar to what we did in the DC circuits, where we consider the power supply to be a short, and then you look in on terminals A and B. And when we do that, we see that the inductor and capacitor are effectively in parallel, which gives us a Thevenin impedance of negative J10, so it's all capacitive. To calculate the Thevenin voltage for this particular circuit, we can use a voltage divider. Here the voltage divider is the impedance of interest over the series impedance multiplied by the source, which gives us a Thevenin voltage of negative 120. Stated another way, that's 120 volts at an angle of 180 degrees. Now, this particular problem, that's just how it worked out. Our voltage source and our voltage Thevenin ended up being the same, 120 volts in both cases. That will not always be the same. It's actually quite uncommon. Before we leave, we should sketch out the Thevenin circuit. Again, 120 volts at an angle of negative 180 degrees with a J10 series capacitor. As a demonstration, let's go to the simulator and see what this looks like. So we start out with a source of 120 volts RMS, 60 hertz at a phase angle of 0 degrees, and inductance, an impedance block set here to have a very small resistance and 10 ohms, 60 hertz, and then here's the capacitor with a very small resistance, negative J5, 60 hertz. Turns out that the simulation doesn't like when you put in zeros for the impedances. We have terminals A and B, and to that I've connected up a 50 ohm load. Again, doesn't have to be 50. 50 was just a nice number. Here we see our Thévenin equivalent circuit. So again, 120 volts RMS, 60 hertz, except this time it's 180 degrees, and this impedance block holds our capacitor at negative J10. Terminals A and B, and again with a 50 ohm load. When we run this circuit, we see the RMS voltages are pretty close to each other at 116 and about 118 respectively. If we were to graph it, we see they're almost identical. You may be able to just see a tinge of green. And there you have it. We have completed a Thevenin equivalent circuit. We've modeled it, and then we've run a simulation, and we've shown that the circuit responds the same as the original circuit with a 50 ohm load attached.